okay. That's like, alright. Hello. Let me see. Is it working? It's still not going, huh? Oh, let me okay, so here we are. I popped the chat out. Oh, let me take a deep breath here. Yeah, I wasn't doing too well earlier today. I ate some food, which generally kind of helps. I was saying that it's not so much that I wasn't doing well physically, it's more so that I was not doing so hot emotionally, right? Mentally and emotionally. Just thinking about different things, it was definitely bothering me. But I ate some food, and usually after I eat some food, I feel a little bit better. So, in a warehouse, there's a row of barcodes where the ith barcode is barcodes of I. Rearrange the barcodes so that no two adjacent barcodes are equal. You may return any answer, and it is guaranteed an answer exists. Oh. Really? Okay. Huh. You could do a round robin. That's a really simple way of doing that. So you get a frequency map of the barcodes, and then what you do is you round robin the one that has the you don't have to do the most, you just do like 1, 2, and 3, then 1, 2, and 3 again, and no, that doesn't work, does it? Oh. Huh. Nope, don't do it that way. Other way. 1, 2, 1, 3, 1, 3, 1. I think you just take the yeah, this is really straightforward way of doing it. I know what to do. This is very similar to another question that I've looked at. You just use a heap. Yeah. Pop and push in the heap. So we're going to say for each, so we'll do the following. So int frequency, bound 10,000. Let's say 10,001. Fill this with zeros. Each int x, and we're going to call this vs. Keyboard's bouncing around over here, which I don't really like, but okay. And we're going to have a vector of pairs, ints, and it's going to be bool. Actually, int is what I want. Yeah. Do it that way. That's fine. So call this h for heap. Say for each x in frequencies. Oh no, less than bound. Say if frequency of I is greater than 0, then we're going to say h dot push back, replace back. Yeah, okay, place back. Which I don't remember exactly how to do that. Yeah, my keyboard is bouncing around over here. I think I could push back to the pair. I don't recall. I think I could do it this way. It's going to be and 0 is actually what I want. Yeah, we'll come back to that. Oh, that's pretty awkward. Maybe I want a tuple. Pairs are a little bit easier to work with, though. That's actually a good question. Interesting. I could have a comparator. Yeah, that's fine. It's a little bit awkward. Yeah, okay, we'll do it that way. Actually, it's going to be P1 and P2, I forgot. There might be a better way of doing this, but let's just do it like this for now. F1 is going to be P1, it's going to be frequency of P1 dot first. 2 is frequency of P2 dot first. Frequency 1, frequency 2, and then the second values are, yeah, so we'll do, so F1 and F2 are equal, and P1 second is less than P2 second. So it's actually, P1 second, P2 second, I'm going to, in this case I could use booleans. So basically, I mean, int is fine, it's fine, it's fine. Okay, might be faster with a boolean, but whatever, we'll just leave it as is. So these are going to be, they're going to prioritize the smaller value first. The way the heap works, this is a bit confusing, you have to remember this. Heap, it goes backwards, so a max heap uses the less than operator. A min heap uses the greater than operator, so if you want something to be smaller, as in 0, you need to use greater. On the other hand, if you want something to be larger, you got to use less than. So we want the larger frequencies coming first, and the smaller second values coming second. Yeah, so if they're equal, then we're going to check the second values. If they're not equal, then we check this other value. All right, pretty straightforward. So we can use that. Just do it this way. It's simple enough. Okay, great. So then we say make heap of h begin, h end, comp. Now we're going to have standard vector int result, standard result dot reserve. It's going to be yes dot size. Okay. I think that's fine. Yeah, I guess I don't actually need to do all that. I think this is fine. All right, so now we're going to say while h is not empty, say if auto let's do it this way. So say it, so let's do const int val. So just do int val. Let's do it that way. Int val. So let's do while int val equals h of 0 dot first. Say while oh, this is confusing. Trying to think about this. Hold on a second. I kind of messed something up. It's 10,000. All right. This shouldn't be as hard as I'm making it out to be, but kind of making some mistakes. So while val is 0, we're going to say standard pop heap. Actually, I don't even think that's what I should do. Let's not do it that way. Let's not do it that way. Oh, gee. You know what? The problem is, problem is the following. I want to update it at each iteration. Trying to think of a quick, efficient way to do this. What I want to do is at each iteration, I want to update the second value. Everything that has a 1, update it back down to 0. What's awkward about that is I don't want to spend the extra time, if that makes sense. Actually, with this particular question, I could do it even more efficiently because all I have to do is just check the previous value, that the value that I want to push is not the previous one. If it is, then I pop that off and then get the next one, then push that one back on. Yeah, it's not really that important, I guess. Yeah, I mean, I can keep this a lot simpler. Actually, keep it way simpler. There's like a more sophisticated way of doing this if you needed to have more than just one kind of space between the elements. Yeah, that's fine. Okay, we can do it this way. Ow. Oh. Although the comparator is going to be still a custom comparator. It's just a little bit different. So again, use greater to get a min heap, which actually I want a max heap, so I would use less than. It's fine. Okay. So what we do is we say if result is not empty, and result.back is equal to, so we'll say int val or index, or yeah, val to h of 0. Result.back is equal to val. We could just say h of 0 actually. Then pop heap. Hold on, I'm not sure. We'll come back to that. Pop heap. Then set val, we'll do it this way, int val h of 0. and then update val to age of 0, and then push back. Oh, so previous value is value, then push back the previous value, and push heap. So basically just skip it and get the one underneath. And then what you're gonna do is result.pushback val, and then say frequency of val decrement, and then say if frequency of val is less than or equal to 0, then we're gonna pop that out. It's something like this. It's a little bit complicated what's going on here, but something along these lines. Let's see if this works. I think it took a while to do this, longer than I should have. If I do it on time, 16 minutes, yeah. Something like this. It could be, oh, I got it. Okay, I was gonna say it could be wrong, but nope. All right, let's just generate some, test cases. So some of these test cases could be, we said for I in sequence, 1 to 8, right? Do, say echo hello, done, right? Okay, and then I want an awk script here, which is going to be awk begin, and we're gonna have a for loop in there. There's a little bit more to it than that. I actually want echo. This also can be, this awk script can be like so, and closing. Okay, that works. And this awk script is actually gonna have a sed at the end as well. It's gonna be s forward $, empty, okay. And that'll remove the last character, and we'll do srand. Now the way I did it last, yeah, I think this is a reasonable way to do it. You could do date plus %s %n get line, pipe that into get line, and put that in a seed variable, and srand that seed variable, and then for I is 0, I is less than, I think I wanted 10,000. Let's do 100. Increment I. Let's do another variable x. We're going to say x equals something with x. We'll do rand, it's going to be int 1 plus 10,000 times rand. And something like this should give me what I want. Okay. Okay, one more detail is to, after this for loop, print x. There we go. Nice, beautiful. That's a lot cleaner. I think now I've got some practice with this. I could do that a lot faster. It's good. We'll do like 3 of these, and then I'm going to do another one. One. 2. 1, 2, third one, 3, and then there's a couple, maybe a couple more I want to do. Some what you would call fuzzing. Doing some fuzzing. So here I want to also test when the values are kind of tight, when they're sort of close to each other. And I'm going to make them a little bit less tighter. A little bit less tighter. Not as tight. Invalid test cases. Okay. Ray has no valid answer. Okay. Let's try these little ones. These might be too tight. No. Okay. Try again. High probability these don't have answers, because I didn't really specify the test cases in that way. Maybe we'll just do like 2 of them. Right, I think I mentioned that you kind of have to, sometimes have to specify the test cases in such a way that they actually work. And sometimes it can be kind of annoying to get that to work properly. Okay, those are too tight. These are too tight. Too tight. The values are too close to each other. There we go. Okay, I think it works. I'm gonna go for it. Could be wrong, but I'll try it. No! Oh! Gotta be kidding me. No. Really? Oh. Shoot. Unbelievable. No, really? Well, okay. That's kind of one of the downsides when you try to fuzz it and you don't really take the time to go through the various test cases. Alright, so why is this wrong? Output 2151 expected. What? Why wasn't there a 2? Wait, what? What happened with my code? Huh. Oh. Oh, shoot. Okay. Put back. I did that wrong. I kind of thought about it, and I sort of considered this, but I didn't really think it all the way through. Yeah, there was some things involved here that didn't occur to me. Is this what I needed to do? Did something strange there. It wasn't quite what I was supposed to be doing. Is this? I don't know if I should go for it again. I could try and go for it again. Maybe not a good call. I didn't really think about it again. I just kind of was like, all right, I'll try it. Oh, that works. Okay, yeah. I had the right idea. I just kind of maybe went through it a little bit too quickly. All right, not great that I got an incorrect answer there, but not the worst. Relatively fast too. Yeah, so I mean, I think the basic idea is there. It's basically you just you organize them by their frequencies, and then what you're going to do is try to insert an element, the largest frequency element, decrement the frequency, and the next element you try, if the previous element's the same, then you're going to remove this element, take the second largest, use that one, decrement the frequency, possibly even pop it, and then return the one that you removed from the top back. Excuse me. Yeah, not too bad. All right, we're gonna submit this 6 times total. I think 7. No, we're gonna do 6 more times. So it's gonna be too bad this doesn't scroll this part. So it's gonna be 1. I can't see how many times I submitted. 1, 2, 3, something. I think I did it twice, so I want to submit 7 times total. So we'll do 5 more times and see what my run times are each time. It's like reasonable runtime. Yeah, it's relatively quick to program. Simple idea. That's 2. We'll do 3 more, and then what I'm going to do is look to try another question. It's pretty good on memory. It's reasonable on time. So 2 more clicks after this. And yeah, I mean, this is very similar to some other questions that we've seen. Actually, a question that I've solved already. The question was like, if you had like a certain 90% is pretty good. A certain amount of I think one more. You had a certain amount of what do you call that? If you had a certain amount of time, you had to wait, like what they call it, like a quote unquote cooldown before you could reuse an element. If they all had a certain cooldown, like how could you rearrange the elements? I think that question, they weren't really looking for so much how do you rearrange it, but what would the, like, there might be empty spaces between your elements, like how many elements would you need to, like how many spaces would you need to use, I think, to fit all the elements. But in that question, like this algorithm, you could use this directly to get something. And yeah, it's a little more involved though, that question, because the cooldown part is significant. Like here, I didn't have to cool anything down, so to speak. And I kind of was thinking, like, I don't know if to efficiently cool things down, you may have to use a what's that called? May have to use like a queue, or I was going to say a segment tree, but I don't think a segment tree is necessary. I think you can, because the cooldown, you should use a new element at every iteration. If the queue is empty and then you put something in there, then you have to wait a few iterations before you can start to use the queue. I guess you could put some dummy elements in the queue or something, but you would pop an element off of the queue, because you're only going to use one element at a time and refresh the cooldown one element at a time. So you're always, and then that element is going to be decremented in its position in the queue. So you could just use a queue to kind of get through the elements. So I could have used a queue for this as well. That may have been easier to do it that way. But this works also. Just removing it and putting it back in is fine too. So yeah, I think a queue solution is probably better for this sort of thing. But yeah, it's good. It's good. I've seen a similar question, so that wasn't too bad. But it took me a while to program that. Yeah, okay. So I'm gonna stop here, restart another question. Thank you for watching. If you like that, give that a like and follow the stream. I'll get on to another one now.